Hello good day viewers, you are welcome once again to Shabes online tutorial. Our topic of today's tutorial is introduction to differential equation. If you are new here, consider subscribing to my channel and also follow me on Facebook, TikTok, Instagram at Shabes online tutorial. So what is differential equation? And a differential equation is an equation that containing the derivative of one or more dependent variable with respect to one or more independent variable. And under this differential equation is classified by type, order, and linearity. So we are going to start from classification by type. So under this classification by type, we have what we call ordinary differential equation and partial differential equation. So ordinary differential equation can be written in the form ODE, ordinary differential equation, and the second one is partial differential equation. So we're going to start from ordinary differential equation. An ordinary differential equation is an equation that contains the derivative of one or more dependent variable with respect to a single independent variable. So we're going to give example under ordinary differential equation. So example, when you have a differential equation in the form dy over ds plus 5y is equal to exponential x. So this is an example of ordinary differential equation, because from the definition we say ordinary differential equation is an equation containing one or more independent variable with respect to a single independent variable. So if you look at this equation, differential equation, y is dependent variable here because we are differentiating y with respect to x, and the independent variable is x. The independent variable must be single in ordinary differential equation. So you can have another differential equation in the form dy over ds plus du over ds is equal to 0, for instance. So if you look at this ordinary differential equation, from the definition we say it containing one or more dependent variable. So the dependent variable here is y and u, but with respect to a single independent variable. So the variable here, the independent variable is only x. So these are some of the examples of ordinary differential equation. So now let's move to partial differential equation, PDE, partial differential equation. An equation is said to be partial differential equation. It's an equation that contains the partial derivative of the function of independent. So partial derivative is an equation that containing partial derivative of one or more dependent variable with respect to with respect to two or more independent variable. So let's see some example. When you have delta y with respect to delta x, then plus delta u with respect to delta t is equal to 0. So if you look at this differential equation, the dependent variable here is y and u, then the independent variable is x and 2, and from the definition we say a partial derivative differentiation. A partial differential equation is an equation that contains partial derivative of one or more dependent variable with respect to two or more independent variable. The independent variable must be two or more, but the dependent variable is one or more. But in this case, we have two dependent variables and also two independent variables. So this is example of partial differential equation. And again, we can have another example, delta t with respect to delta y, then plus delta t with respect to delta s plus 5x is equal to 0. 5t is equal to 0. This is another interesting example of partial differential equation, because if you look at the dependent variable here is t, and we say a dependent variable is one or more. So, but independent variable must be two or more. So in this case, we have two independent variable and one dependent variable. So this is the differences between ordinary differential equation and the partial differential equation. This partial differential equation is represented by delta y because it's an equation that containing one or more dependent variable with respect to two or more independent variable. So this is all about classification by type: ordinary differential equation and partial differential equation. Now the next thing we are going to look at is, and the classification by order is the order of the highest degree of the derivative in an equation. So let us see some example. So under this classification by order, when you have a differential equation in the form dy over ds plus 6y is equal to exponential x. So if you look at this differential equation, this is at first derivative because dy over ds is the first derivative of this function. So the order of this differential equation is first order differential equation. So we can also have second order, can be represented as d square y over ds square then plus 5y is equal to 0. So this is second order differential equation, and this is in Lebre's form. Differential equation can also be written in prime notation. So you can have something like y prime plus 5y is equal to 0. So this y prime can also be written as the square y over the s square. This is still second order differential equation. So we can have, so when we have y over the s cube, then plus dy over ds all to the power of 4, then plus 3y is equal to exponential x. So the order of this differential equation, somebody may say is 4, but this is not 4. Mind you, this one in the middle here is just the first derivative raised to the power of 4. So what we are going to consider here is this: the cube y over the s cube. It means that this is a third order ordinary differential equation. It's an ordinary differential equation because the independent variable here is only single x. But when the independent variable is 2 or more, it will be partial differential. It will be third order partial differential equation. But in this case, this is third order ordinary differential equation. So that is all about order of differential equation, classification by order. So the next thing we are going to look at is classification by linearity. So under this classification by linearity, we have linear and non-linear differential equation. So in my next video, we are going to learn how to differentiate between linear and non-linear ordinary or partial differential equation. Thanks for watching, and please follow me for more, and also subscribe to my YouTube channel.